In this lesson, you will learn to apply the definition and theorem of perpendicular lines. Now, what do we mean when we say perpendicular? Well, lines are perpendicular if you have two lines that intersect to form right angles, meaning that we have angles that are 90 degrees. So for example, over here, we see that line AC is perpendicular to line BD. So that is how we would say that. We would say that AC is perpendicular to BD. Now, using math notation, instead of writing out that phrase is perpendicular to, what I can do is use a symbol instead. And the symbol is an upside down T. So we see here an upside down T would have 90 degree angles. So it's really the shape of two lines intersecting at a 90 degrees. So in math, we would say AC, and then upside down T, and then BD. And by the way, in a picture, if you have perpendicular lines, you can show that by drawing a little box in the corner. So a little box in the corner means that this angle is 90 degrees. Now with perpendicular lines, we have two theorems, which are actually kind of the same theorem, just stated backwards. And the first theorem is, if two lines are perpendicular, then they form congruent adjacent angles. Which would make sense, right? If they're perpendicular, then this would be 90 degrees, and then this would be 90 degrees. Angle 3 is 90, and angle 2 is 90. So all the angles, all the adjacent angles, which are the ones that are touching each other, they would all be congruent. They're all 90 degrees. And the other theorem is basically the same thing, except stated as the converse. So remember, converse means you just switch the if and the then statement. So instead of saying if two lines are perpendicular, we would say then the lines are perpendicular. And instead of saying then they form congruent adjacent angles, we say if they form congruent adjacent angles. So we just change the order of the if and the then statement. And so we have basically the same thing. If we have congruent adjacent angles, meaning if they're all 90 degrees, then the lines are going to be perpendicular. Now, this is a theorem, and theorems must, by definition, be proven to be true. We cannot just assume them to be true. So we're going to prove that very quickly, where we are given that the lines are perpendicular. So that is your given statement. We are told that line L and line N are perpendicular. So notice the perpendicular sign. And the reason is because it is given. It is told to you that they are perpendicular. Well, the definition of perpendicular says that we have 90 degree angles. So we know that angle 1, 2, 3, and 4 are all 90 degrees. And the reason we know that is because that's your definition. And then if they're all 90 degrees, based off the definition of congruent, we can conclude that all of these angles are congruent, because congruent means that all the angles are the same measure. So we can finish by saying angle 1, 2, 3, and 4 are all congruent angles. And that is because that's what congruent means. That is your definition of congruent angles. And we're already done with the proof. Notice that is what we're trying to prove. We are trying to prove that they form congruent adjacent angles, which is what we have right here. We have all the angles being congruent. And that concludes the lesson for today, and we will see you next time.